Hi everyone, this is a video on esterification. Esterification is a very specific type of organic reaction. It's when a carboxylic acid reacts with an alcohol to produce an ester and HOH, water. We're going to end up pulling that water out of the two molecules as we attach them together. Because of that, we call it a condensation reaction. Here's two examples. First, ethanoic acid reacts with methanol. Notice how I've drawn those two molecules so that their functional groups are pointing toward each other. It'll make it a little bit easier to visualize how we're going to attach them together. We're going to pull the OH off of the carboxyl group of the acid and take this H away from the hydroxyl group of the alcohol. Look at that, H, OH. I'm going to pull that out, and there it is, HOH. Then what we're going to do is, this bond, it has to go somewhere. It's going to attach to that oxygen right there. And so here we have it. We have there's the acid side of the molecule bonded to the O that was left behind from the alcohol to make our ester. Remember that when we're naming an ester, we want to name the alcohol side first. Look at that. We had methanol. Here's the remains of that molecule with one carbon in it. It becomes methyl. The acid side, the double bonded oxygen, was left behind on the carboxyl group. And here it is. It's a two-carbon group. It's ethanoate. We produced methyl ethanoate. A second example, this time I wrote the alcohol first and the acid second. But again, note, I drew them so that the functional groups are pointing toward each other. Now, it might seem a little bit strange to have this HO like that when we're used to writing it as OH, but this is just a better way to reflect the actual structure. The carbon is attached to the oxygen, which is in turn attached to the hydrogen. Once more, we're going to pull the water out, H and OH. Pull that water out, and there it is. Okay? The bond that was left behind from the carboxyl group attaches to the oxygen in the former alcohol. We link them together. And again, the alcohol gets named first. We had propanol, this three-carbon group. It's here written first. We have propyl. We also have a carboxylic acid, butanoic acid, that has the double bonded oxygen. Here's the double bonded oxygen in the ester. A four-carbon group is butanoic acid. In the ester, butanoate. We produced propyl butanoate. This does really help to emphasize the idea that an ester has an alcohol side and an acid side. The side where the double bonded oxygen is located has its origins in a carboxylic acid, so we call that side of the ester the acid side of the ester. The other side then is the alcohol side. But once more, when we write the name out, we start with the alcohol name first, and then the former acid second. And I hope that helps.